point out in this research set is a measure that we can then generate by looking at the respiration rates and the C-N ratio, but also the amounts of carbon and nitrogen that are soluble. We can calculate how much nitrogen will potentially be mineralized from that organic source in the soil. And by organic, I mean organic matter, humus, easily decomposable plant residues, those sources of organic nitrogen that are present. So you can see the row crop, there wasn't much organic matter in the soil to start with. It has a very low potential to release more nitrogen throughout the growing season, whereas the pasture and the grazed CRP actually have quite a bit of potential. And the nitrogen would become available as the season progressed and the crop would use it. I should note that the pasture had a fair amount, maybe 25% of legume in the pasture mix, red clover or some white clover. The CRP grazed had a little bit of red clover, but not much. The CRP ungrazed had zero legume in it. Mostly rough warm season grasses in that. So why that has a lower nitrogen mineralization, probably just a lower nitrogen content and a lower soil health score kind of leads to that too. There is a measure that we also calculate that is related to this, which tells you how much phosphorus could be available over time from organic matter. And these numbers are generated from the principle that carbon to nitrogen ratio is usually 10 to 1, and then nitrogen to phosphorus ratios are also usually 10 to 1. So carbon to phosphorus would be 100 to 1 ratio. So those numbers are in the background of why these calculations can work and why they do work in practice. So, next slide.